Hello all, welcome back to the channel and welcome to the course on real analysis. Recall in the last lecture we have seen about the closed set concept and the concept of limit point. So if the A complement is open, then set A is closed, right? We have understand the definition as the set a set A belongs subset of R is said to be closed if A complement is open. Then if A complement is open, then the set is closed. And we have seen some properties like arbitrary intersection of closed set is closed, right? Other than that, we have seen about the limit point of a set. So a set point, a set of point x equals to a is said to be a limit point. So basically, a point is said to be a limit point if the set A is a subset of R and if it is every neighborhood of continuous infinitely many point of each other, then या फिर इसके अलावा ये बोल सकते हैं कि अगर नेबरहुड सेट के अलावा इसका इंटरसेक्शन अगर ए के साथ ले तो वो फाई सेट के बराबर आए. ठीक है. So we have seen that if every neighborhood of the point of a set contains infinitely many points of the set A, then this is also said to be the limit point. And if 2 implies 1, so the point number 2 implies the point number 1 definition. And we have seen that the limit point, how to calculate the limit point. So here we have seen the important note, like there is no way to find the limit point. You have to make estimations to find the limit point of by Archimedean property and verify the same, right? And no finite set have a limit point. So most important thing that if the set is finite, then no finite set have a limit point. किसी भी finite set का कोई भी limit point नहीं होता है. Having an infinite set, then it implies that having a limit point implies that it is an infinite set, but infinite set doesn't implies that the set having the limit point. Other than that, we have seen that the natural number set, so natural number set has no limit point because it is a finite set. And of course it if union with the finite set, then this intersection with the natural number set is phi, so that implies that natural number has no limit point, right? Because it should be non-phi, it should not be empty, right? Then we have seen that the boundary plus infinite set should be implies that the set has a limit point, and we have seen some examples. But if the set is bounded, it doesn't guarantee that the set has a limit point, right? Now in this lecture we are going to see about a topic called derived set. So let us start with the definition. Derived set. Derived set we will be going to see. So according to the definition, a set a set of all the limit points of A, all the limit points of A is called derived set, right? Of A. Derived set of A is the set of all the limit points of A. And if I talk about the notation, students, then the notation is A dash, right? So now importantly, I will be making a comment here. So take a note of it. Key set A is closed. Set A is closed if A dash, the set of derived set, is a subset of A. So if it is a subset of A, then the set A is closed, right? Now we will be discussing some example. So I will be making a set. I will be telling that it is a derived set or not, and whether this set is a closed set or not. So let us start with the empty set. So recall empty set has complete neighborhood. So empty set is of course a subset of itself empty. So again a dash is also phi derived set of limit points because each of the neighborhood, so each of the limit point is what neighborhood points, all the neighborhood points. And for the set of limit points, so phi, again derived set is what for phi, the set of limit points is all of its points, right? So therefore it comes that phi has a derived set as all, and it is a closed set because phi contains inside phi, right? Now if we talk about singleton set A. So singleton set A has a derived set as phi empty set, and of course we know that derived and this singleton set, empty set is the subset of the singleton set, so therefore it is closed, right? Now if I talk about the finite set, now comes the twist, students. So again if we see, then it is the phi set, because the no limit point has, this set has no limit point. Similarly, no finite set has limit point, so derived set is phi, and again this set is a subset of this empty set, so it is again a closed set. And recall, if we go by the definition of the closed cell as well, then we came to know that A complement is open, and again A complement is what? Phi. So if A complement is open, then A is closed set, so this set is a closed set, right? Phi set is a closed set. Now if we talk about natural number n, the natural number n again has a no limit point, as we have seen in the last lecture. So again it is a subset of natural number, and if it is a subset, then this is a closed set, right? Now if we talk about z, so if z, so what I am saying, I have write the notation as, if I recall, then I have write the notation as A dash, and I have said that the set A is closed if A dash is a subset of A. So I will be commenting on this closeness of the set basically. So the singleton set A, the finite set A, and the finite set and the singleton set, sorry, the singleton set A and the finite set and the natural number and the integers. So again the set of integers is a no limit point. So it is a subset. So that is why Z is a closed set, right? Again if I talk about Q, now see, now is a difference. So Q has set of limit points as R. So basically now derived set is all the set of R. So it is now, so Q is not a subset of R, right? So therefore it is not a closed set, right? Now if I talk about Q complement, so irrational numbers, again the set of irrational numbers being the limit points at R, as we have seen, so it is not a subset, so it is not closed, right? Number 8, it is R. So R, again R has a limit point of R, this is uncountable infinite interval, so it is again a limit point. It has the subset of R and it is a closed set, right? Now if I talk about the open interval 0 1, so let me tell you, it has only two limit points, right? So it has all the limit points including 0 and 1, so it is 0 1 closed, but 0 1 closed is not a subset of 0 1, so it is not a closed set, right? So if I want to calculate the meaning of closed set, or if I want to check that whether a given set is a closed set or not, what I will do, I will make a derived set of all the limit points, and then try to just see that whether the set of limit points or derived set is a subset of the given set or not. And if it is a subset of the given set, then the set A is closed, otherwise it is not. Again if I say I will make 0 1 0 closed, 1 open, then I say that this is again a set of limit points at 0 1 closed, so again it is not a subset, again it is not a subset, so it is not a closed set, right? Now if I say 0 1 closed, now if I say 0 1 closed and it is derived set as 0 1, it is a subset, so now it is a closed set, right? Okay, now if I say 0 1 0 open, 1 closed, then again it is not a closed set because it is not a subset. The set of limit point derived set is not a subset of the open semi-closed 0 1, right? Now I will say that I will write 1 upon n belongs to n. So this has a limit point. The set of limit point is the only singleton 0 for which the set is not a subset, so it is not a closed set, right? Now let me see if I can write 0 singleton set union, so 1 comma n to n. So now it becomes the set of limit points as phi union singleton set 0, which is 0, and the 0 set is a subset of this set, so it is a closed set, right? So by small manipulation to the 13th number problem, I have made a closed set, right? So it sometimes happens that you need to calculate the closed set or form the closed set, then you can see which set of limit points satisfy the condition. Now the 15 number question, 1 plus 1 upon n. So here we can see that it has only singleton limit point 1, right? So if it is has 1, then singleton set 1. So singleton set 1 is not a subset of this, so it is not a closed set, right? Now, if I take, again I will apply the same funda that if I make the union of the set this, again I make the union of the set this, then I say that this is a singleton 1 and this is a subset, so it is a closed set, right? Now let me make some more modifications to the set. If I suppose 100n n belong to n. So let us see how much neighborhood. So we have seen in the concept of neighborhood that how to calculate the neighborhood, and if each of the neighborhood head has a infinite set of values and it is a limit point, right? So if I say then this has the 0 as the neighborhood and 0 has a limit point, because only the 0 value has infinite values, so it is 0 is not a subset of this set, so it is not a closed set, right? But again if I take, let me say 1 upon 100 n, n belonging to n union 0, right? Then again it becomes a subset of the limit point derived set, so it is a closed set, right? Now say 1 upon m, wait a second, 1 upon m plus 1 upon n, m and m belong to n, then set of the limit points, right? So set of the limit point, recall. Now it is a tough task, huh? So we have m and n both, so we have to take one time m and one time n, right? So for if taking one time m as 0, basically m as 1, then the set becomes 1 upon n union 0, and if I take other than m, then this set becomes 0 comma 1 by n. In both the cases this is not the subset, so it is not a closed set, right? Now if I take 1, 2, 3 up to n and so on, then this has finite set, infinite set. Again, an infinite set doesn't imply that it is the limit point, so it is phi set is the limit point and it has a, it is a closed set, right? So in the similar pattern you can study many more examples, right? So okay, so for this lecture this is enough. I have understand the, I have explained you to the concept of the limit points, the derived set and the relation between the derived set and the closed set. So I hope I have able to clear the doubts. You can practice with schemata for more such content and enjoy the lectures of reanalysis. Thank you so much and have a nice day.